to is what it's asking us for, okay? And so we're going to have to pay attention to what's being labeled and the different pieces that we're going to try to find. The two biggest common things that we're going to be doing today as well is finding angles or finding arcs. And so we got to make sure we have a really good understanding of the difference between those two. When it talks about angle DEF is an angle formed by two segments, right? So we have two segments that are going to form that angle. And just like we've done way back when we did it early in the year, we got to kind of follow the path of the letters. So we got D, E, F. So it's the two segments that form this angle. So this would be angle DEF. DEF opens up to this arc, okay? Kind of looks like a little ice cream cone, right? And when we look at an inscribed angle, that's kind of what it's going to look like. You're going to have an angle. The difference here is this angle is all the way to the edge of the circle, okay? That's what makes it an inscribed angle. It touches at point E. What did we say on Friday we have to do to get from the arc back to angle E? Half, you bet, okay? So angle DEF is half of 100. Okay, so that would be 50. That would be this angle right here. Okay, then it's asking for arc ED. Well, when it asks for arc ED, we're on the outside edge of the circle. Whenever it has this arc symbol here, it's on the outer edges of the circle rather than an angle maybe on the inside of the circle. Because these two pieces are marked congruent, what do you suppose would be true about the two arcs there? They're the same, okay? So this and this would be the same. I would say these two are congruent, okay? And I'm not necessarily I'm gonna use a different marking here because this is a segment, this is an arc, but we can still put a marking on it to show those are congruent. What do we know about a full circle? 360, okay? So I can take 360. If I labeled this as X and this as X, then I could take 360 minus 100, which is 260 degrees. Okay? And so because this is going to fill up the rest of my circle, right? I'm going to take that 260, and because I know those two are congruent, then I can divide both of those by 2. And so each one of those. I know it doesn't ask us to find FE, but guess what? We found it, okay? Because we know ED and EF are the same. All right, let me ask you this real quick here. What if I did this? And let's say I call this A right here. And I ask you to find angle DAF. Where are those two segments meeting at? If I were to redraw my circle here, at the center, right? So this is D, this is F, this is A. We already identified that this arc up here is 100 degrees. So that central angle, it's at the center, so we call it a central angle. What do you think it's going to be? Yeah, and that's what we talked about early in the chapter, right? This would be angle DAF is 100 degrees, okay? And that's one of the ones I really wanted to get at because that's probably the most common mistake that a lot of people are going to make here, right? Angle A is at the center. Whereas angle E is an inscribed angle. right here, and it's going all the way to the edge of the circle, right? So these are two different angles. This angle here is 100, whereas this angle is 50. If it goes all the way to the edge, it's going to be half of that arc. If it's at the center, it'll be the same as that arc, okay? You really have to ask yourself that question. That's the question you're going to ask yourself over and over again is, where is my angle? Where is my angle located? What type of angle is it? Those are all different questions, but kind of asking the same thing. Okay, so really, really important. So that's why I wanted to kind of tie in what we did on Friday, because we're going to see some of those things again today. Any other questions off any of the examples from Friday since I was gone? Anything not make sense? Okay. So we're going to 10.5. I'll kind of leave that out since we just kind of reviewed that. Like I said, if we don't have time to add our formula sheet today, we'll have some time tomorrow where we can probably do that. Just kind of start adding to it as we go, and we'll keep adding to it a little bit each day. Early here from Friday and then today, we are talking about angles and different types of angles and where are those angles located at. Friday we had the inscribed angle. This one is kind of similar because if I look and see where they meet on the circle, right? So it's very, very similar to what we did on Friday. The only difference is on Friday it was typically two chords that met on the circle. Here we have a chord, right here, chord, and we also have a tangent. So a tangent and a chord are meeting, okay? Now, this chord is not necessarily the diameter, okay? If it was the diameter, then we've already talked about how they form a 90-degree angle because it goes through the center, which would make it the radius, okay? Here, it's not necessarily going through the center. So it might be helpful to say this point right here is the center. That chord is not going through the center, okay? And that's what it's talking about as we go through here. It's just a random chord, okay? And if I wanted to find angle 1 right here would be half of arc AB. So it's the same formula we did on Friday, okay? Because it's on the circle, the arc that it opens up to, this is the arc that's between those two segments or lines, okay? Form whatever degree, okay? And all I have to do is divide it. Same thing for angle 2. Angle 2 right here opens up to this arc right here. And so I would take this arc, BCA. Notice it's a major arc because there's 3 letters. Arc BCA divided by 2 gets me back to angle 2. Okay? Let me put in, I always think it's good to put in some numbers, right? So let's say I put in 80 degrees. Let's say that arc right there is 80 degrees. So what would be the measure of angle 1? 40, okay? Half of that arc. So angle 1 would be 40 degrees. Okay? If I know that this arc right here is 80, what does the rest of the circle have to be? How many degrees we got in a circle? 360, okay? 360 minus 80 leaves us 280 on the rest of the circle. That would be this arc right here. And so there I would take 280 divided by 2. Hey, here's another, and this is why I'm kind of showing you with numbers. What is this right here? Well, we said that this is a tangent. In this case, it's a tangent line. What do we know about a line? How many degrees does a line make? 180. 180. If I put together 40 and 140, what do they make? 180, right? Everything kind of works together. And so kind of nice, right? And it kind of backs up everything we've talked about as we've gone throughout the year. And so by putting some numbers in there, it kind of helps everything make sense. Now, am I always going to find all of those different angles and arcs and everything? Not necessarily, but now you can kind of see how they all fit together a little bit. Okay, line M is tangent to the circle. Okay, so here's line M. Line M is tangent to the circle, which means kind of like scrapes along the edge, intersects it at one point. and it intersects it right here at point B. Angle 1 opens up. I always kind of like to, I know it'll be a little bit harder, especially like on big ideas, but I always kind of like to just put that arc in there. This is the arc that it opens up to. Here's my segment and my line. This is the arc we're talking about. So if I have to go back, if I have a 130 degree arc, what do I do to get back to angle 1? That's the good thing about today, is at least early on in our lesson today, we just divided by 2. Very similar to what we did on Friday. Okay, the only difference about the second one here is we're going the opposite direction. Here they give me the angle. This is the angle we're looking at right here. Okay, that angle opens up to the arc between these two. So it starts at K and it comes all the way around to L. So it's a big arc, right? So my answer should be a little bit larger here than the last one. But pay attention to where I'm at. I'm already on the circle right here. So what would I have to do to go from the inscribed angle up to the arc? Multiply it by 2, okay? So here we're going to say measure of KJL, arc KJL, is 125 times 2. Okay, and these are all labeled in degrees because they're angle measures or arc measures, and that's what that little m is referring to. Okay, I'm not going to do every single example today because we got a lot of examples today. Okay, second theorem, and this is where all of these are going to now start to pay attention to where is my angle at. So far we've talked about the angle being at the center. That was early on in the chapter. Friday was on the circle, and then we just described another one that's on the circle, but is formed by different pieces, segment and a line, a tangent and a chord. Here, angle 1 and angle 2 are inside of the circle. They're not at the center, okay? If I were to put the center on here again, those two are not meeting at the center, okay? So it's not a central angle. And we don't really know where the center is at, but we can't assume it's at the center unless it tells us it's at the center, or if it tells me what the center of the circle is. So what we're going to have to do here is a little bit different formula, okay? What it says is we're going to add, for angle 1, the 2 arcs that it opens up to are the 2 that are on opposite sides of it, okay? And what we know here is we essentially have vertical angles. So I could also label this right here as angle 1 because those 2 are vertical angles. So I could either be talking about this angle here or I could talk about this angle right here. Those 2 are vertical angles, so they're the same, right? Those 2 angles open up to 2 arcs on either side of them. Over here, it's arc AB. Over here, it's arc DC. So what we have to do is we have to add those 2 arcs together. The formula they write here is to add them up and take half of it, but I think it's easier just to do divide by 2. Okay, so I would rather divide by 2 rather than taking half, but it's the same thing, right? And so that the formula says take half of it, you could just divide by 2. Okay, to find angle 2, same thing here. This is also angle 2 right here. These 2 are vertical angles. So this angle and this angle are congruent. The 2 arcs that they are opposite or match up to would be arc AD and arc BC. Those are the 2 arcs that match up there, okay? Once again, I would add these 2 arcs together, divided by 2, and it gets me angle 2. Okay? So I'll put some numbers in with it here in just a second, but that's when, this is our third one, it's when it's inside the circle, but not at the center. Okay, so try this one right here. Using that formula, we're looking for angle X. Looking for this angle right here. See if you can find out what that is. I always kind of like to mark somehow what two arcs those two open up to, right? And so here the two arcs that they open up to are these two arcs. Now here's the first thing I want to show you. This is why we have to have a different formula here, okay? This is not at the center. If this was at the center, then this would be 156 and this would be 130. Well, these two have to be equal, right? And if I said this was 130 and this was 156, that immediately tells me it's not at the center, right? Because those two are vertical from one another. So pay attention to that. Sometimes we don't pay close attention. And does it look like it's pretty close to the center here? Yeah, right? And so it can be a little bit deceiving. And so as I look at this and I say, oh, it looks like it's at the center, so I'm just going to call it at the center. Unless they tell me it's at the center, we can't assume that it's at the center, okay? And use things that we've talked about to kind of help you guide you along here. Those two are not at the center because these two have to be equal, okay? I can't have two different measures right there. So what we're going to do here is we're going to take 156 plus 130 and divide it by 2. Okay, I would probably, I'm going to tell you this right now. This is a common mistake that people make. Depending on the type of calculator that you have. If you type it into your calculator like this, what's your calculator going to do first in most cases? It's going to do the division first, okay? Your calculator is smart enough that it knows the order of operations. So I would do it one of two ways. I would either put parentheses around these two, add them, and then divide by 2, or do 156 plus 130, hit equals, get the answer, take that answer divided by 2. Okay? Either one of those would get you there, but don't try to do the whole thing at once, because your calculator may not do it right. Some of your calculators, because everyone's a little bit different, do they display the whole thing or do they not display the whole thing? I can't tell you without looking at your calculator how I would do it. So just make sure you understand, make sure your answer makes sense. When I'm taking this here, my answer should be, basically, we're finding the average of these two, right? If I had two test scores, I add them up, I divide by 2. So my answer should be somewhere between 156 and 130. And that's how I would also make sure that it makes sense. So here it would be 143. Okay, the next one's not much different, so I'm going to jump down here. Okay, I'm going to try to find y. Now this one's a little bit different. Y is this arc right outside here. It's the measure of this arc AB. Okay, I could say that y is the same as the measure of arc AB if you wanted to. You don't necessarily have to do that part. So the angle that I need here is this angle right here. This time I don't know that inside angle, right? It's not at the center once again, but it's inside of the circle. So to find out what this angle is, I would have to take these two divided by 2 and get that. But we don't know what y is, so we can't just add them up and divide by 2. But what can I do to find the angle right next to 102? What do I know about these two angles? What do they make? They make a line, right? They make 180, yeah. So if this is 102, what's this guy right next to him have to be? 78. 180 minus 102. Okay? So this is 78 right here. Okay, those are the two arcs that we're referring to that match up to that inside angle. So here's how we're going to set it up. We're going to say y plus 95 divided by 2. We're going to add the two arcs together. Divided by 2 equals 78. So we got a little algebra equation here. We want to solve for y. What would be the best way to solve for y here? What would be my first step? Multiply by 2. Good. So we're going to get y plus 95 equals, and then take 78 times 2. And then subtract 95. So we're saying this arc up here, arc AB, is 61 degrees. Okay. They are not the same. We've got to make sure we understand that portion. All right. This one I think is a little bit tricky. Okay. We're looking to find x. A couple of different ways that you could do that here. Okay. And I'm going to show you what I think maybe is the easiest way to do this. Okay. Let's find this angle first. And I'm going to call this angle y. Okay. So as I look at these two, okay, then I'm going to do 2x minus 1 plus 2x plus 7 divided by 2. Okay, and I could set that equal to y, right? Because we didn't have a y in our original problem, but that is what y is. But what would be the relationship between these two? If I told you that this was 70 degrees, what would the guy right next to it have to be? How would I get this one right here? If this was 70, what's this guy got to be? Landon, what do you think? What do those two together make?
180.
Okay, so if this is 70, how would I get this guy?
180 minus 70.
Yeah, so that would be 110. Here, the problem is we don't know what x is, right? So what we're going to do is we're going to say y is 180 minus x. Okay, and you wouldn't necessarily have to use y for a variable here. I'm just using that. And then we can kind of do like we've done in the past. We can do substitution. And I can take 180 minus x and put it in for y. On the left-hand side, what could I do to simplify this expression? Combine like terms, absolutely. So 2x and 4x, or 2x and 2x make 4x. Negative 1 and 7 make 6 over 2. Okay, now, a couple of different things you could do here. Okay, and I like to kind of show you different things, and you can kind of determine how you want to do it. You could multiply by 2 here, but if I were to multiply by 2 here, I would have to distribute the 2 to the 180 minus x, and that's one thing you could do. Here's what I probably would prefer, if you can do it. We can divide this by 2. But if I were to divide this expression by 2, both the 4 and the 6 have to be divided by 2. You can't just divide the 4 or just the 6. That entire expression is divided by 2, so everything must be divided by 2. So this would become 2x plus 3 equals 180 minus x. Now we're here, it's just, we've solved a lot of algebra equations this year, guys, right? And so we should have a lot of practice being able to do this. We got variables on both sides. Get those variables together. Subtract 3 from the other side. And then we take 177 divided by 3. I always like to finish up by making sure I know what it's asking for, okay? As we saw in the quiz last week, and we'll continue to see on Big Ideas and on the test next week, we're going to ask you lots of different questions. Sometimes it'll say, what is x? Sometimes it'll say, what's the measure of this angle? Or what's the measure of this arc? So make sure you know what the question is that's being asked, Okay, that's on Big Ideas last week. A lot of people were missing it because they would solve for x, they would put 59 in the box, and they would say, there it is. Well, it wasn't saying what is x, it was asking for like the measure of the angle. So then you got to take x, you got to plug it back in. So pay attention to what it's asking us. Up here it says find the value of the variable, so here we're done because we found out what x is. But if it asked us to find a specific angle or side, we would have to do that. Okay, some more formulas. Here's what I'm going to tell you is none of these formulas are overly difficult. Okay, either they're the same, we add up divided by 2. This one, very, very similar, but what's going to be different is where is my angle located at? What we've seen so far is it could be at the center. It could be on the circle in a couple of different formats. It could be inside the circle but not at the center. Now we're looking at an angle that is outside of the circle. So now we have center, we have inside, we have on, and we have outside. So the angle could be really 4 different places, right? And that's the first question you're always going to ask yourself today. And really going forward throughout this chapter. When I'm trying to find an angle, where are those 2 segments or lines intersecting one another? Okay? Or in this case, rays. Here we have 2 rays that are intersecting, and they're intersecting outside of the circle at angle 1, right? Here it's angle 2. Here it's angle 3. But in all 3 situations, they're all a little bit different. Why we give you 3 different pictures here? Because this one is a secant and a tangent. This one is 2 tangents. This one is 2 secants if it was going to continue on. So we have different lines meeting, but they're all meeting outside the circle. So they're all going to use the same formula. The formula that we're going to use here, and I'm just going to write it out in a little bit different format. Arc BC is the big arc. So we're going to take the big arc minus the small arc and divide it by 2. Okay? Just trying to break it down in a little bit easier fashion. But the reason I'm doing it that way is because we're subtracting here, we always got to put the big number first. We always got to put the big arc first. If I put the smaller number first, if I took this minus this, I'm going to get a negative number. We can't have a negative angle measure, at least not in these problems. Okay? So a negative would not make sense for something like this. Sometimes we might get x being a negative, but a negative angle measure wouldn't make sense for what we're doing here. Same thing here. This would be my big arc. This would be my small arc. If I look at the one on the left, or the right, sorry, this would be my big arc. This would be my small arc. And I'll go ahead and label this so you kind of know what we're talking about. This would be my big arc. This would be my small arc. Big minus small divided by 2. Okay, if I look at this one here. Something like this is fairly straightforward. X is on the outside of the circle, right? That's the first thing that we determine. Since the angle is on the outside of the circle, here it's pretty easy to tell what the big arc is, right? Because this is the bigger number. So we would call 178 the big arc. Big minus small divided by 2. So in this case, we would do 178 minus 76 and divide by 2. Really be careful of your calculator again here, okay? Try to do the same thing over and over again. Either put it in parentheses or make sure you hit equals first and then divide it by 2. Because it's really easy to make a calculator mistake on these. X then would be 51 degrees. Okay, this one over here. This is my big arc. Now this is where it gets a little bit trickier because we don't know what the big arc is, right? I mean, it's labeled with A, but we don't know the actual angle measure of it or the arc measure of it. We just know that's our unknown right here. But I'm labeling it as big because that's the formula, right? Big minus small. So I'm going to write A minus 44, because the angle's on the outside, divided by 2 equals the angle, which is 30. Big minus small divided by 2. Just put things into your formula. Don't forget to divide by 2. That's another common mistake that we forget. What would I do first to solve this one? Xander, what do you think? Multiply by 2. Good. Okay. And then simple, move the 44 over. So A would be 104. Okay. I'm not going to do both of these, so let's do the one on the left here, okay? These are just some kind of algebra heavy. Same idea though. This is big, this is small, 25 is my angle. Okay? We're trying to find out what x is here. I would always say here, make sure you're writing this out. Well, that's why we put those extra pages in your guys' packets. A lot of times when I go around big ideas, you guys aren't like working it out, especially a problem like this. You got to work it out. If you say, I can't figure this out, and I come around and you're like not working it out, then I'm going to be like, well, show me your work. Let me see where you got it wrong. But if you try to do everything in your head, you're bound to make mistakes, especially on something like this. There's a lot of steps to something like this. I get that some of them you can probably do without showing work. This is probably not one of those, okay? And here's why. As I look at this, big is 3x minus 7. I would probably keep it in parentheses. Minus x plus 5. Once again, keep it in parentheses. Okay? We're subtracting big minus small divided by 2 equals our angle. I'm just trying to get you an easy way to remember the process here. Big minus small divided by 2. Okay, we did this a little bit ago, but this is why this is kind of algebra heavy again. The reason we want to keep parentheses right here, what am I going to have to do with the minus sign in front? If I have a negative sign or a minus sign directly in front of parentheses, what am I going to have to do with that negative or minus sign? What do you think, Ryan? Yeah. You got to flip the sign. Basically what we're doing here, we're going to treat this as like a -1, and we're going to distribute it throughout. Okay? So we got 3x minus 7 minus x minus 5 over 2 equals 25. Okay. I would say at this point you can kind of combine 2 steps into one. We know we have to simplify the top. We know we got to get rid of the 2 off the bottom. So I'm going to combine like terms up here. 3x minus 1x would be 2x. Really watch your signs here. -7 minus 5 would be -12 over 2. And really, here's where you can combine 2 steps. I was talking about how you can combine 2 steps. We've already done it a couple of times today. If you wanted to go ahead and multiply by 2 at the same time, because those 2 steps are kind of separate of one another, you could do that. And now it's just a 2-step equation. I put a degree on the one earlier. You probably don't need to put degrees on it because we're solving for a variable. The only time you really have to put a degree is when you're looking for an angle or an arc. Okay, this problem right here, but that's going to be a little bit more algebra. I'm not going to do all of them on this page. I'm going to kind of talk about the process. I think what I'll do here is, let's start with one of the top 2. These 2 are basically the same. Pay attention to what's going on here. And this is something we haven't seen for just a little bit. What would I call DA right here? What kind of piece is DA? It's a tangent, okay? It's intersecting the circle at one point, point A, okay? Where is the 135 degrees at?
center?
At the center. Yep, C is the center here. Okay. So we have a radius and we have a tangent. What happens when we have a radius and a tangent? What do we form? A 90-degree angle. Okay. Bless you. So we have an angle at both tangents. A and B are both tangents. We're forming a 90-degree angle. Okay. I have a four-sided figure here. I know 3 out of the 4 angles. How many degrees are there in a four-sided figure? Square, rectangle, parallelogram, any type of four-sided figure, they all have how many degrees? 360. Okay. So all I would have to do here is take 360 minus 135 minus 90 minus 90. What's that leave us? 45. Okay. Now, could I take this angle and use what we've talked about? Probably, but I think that's going to be your kind of go-to on something like that. As I go down to this one here, the only difference here is we don't have anything, we don't have our radius drawn in here. But we know that a radius connects the center to a point that's on the circle. And if you notice again, you could do this like we did just a second ago, right? Where we did then doing it like this. Okay, now, here's where it's going to be different. We're still trying to find out x, and I'm going to show you how you can get to x. And that's why you probably wouldn't recognize this right away, but I'll show you how you can get to x. I still know that this is 90. I still know that this is 90, right? So I could, once again, do 360 minus 50 minus 90 minus 90. And I subtract all that out. And that's going to be angle R at the center. What are we left? How many degrees?
30.
How many?
130.
130. Okay. So angle R is 130. Angle R is at the center. Okay. So if angle R is at the center, what would be the measure of arc PQ? How much? Okay, if this is R right here, and R is 130, then what would that arc be? Remember, it's at the center. To get from a central angle to the arc, it's the same. Yeah, because it's not on the circle, it's at the center. And that's from like very beginning in the chapter, right? So this is 130 degrees. And this is kind of what I showed you early on. Now, if I wanted to get back to X right here, what could I do to this arc to get back to X? And this is what a lot of you guys are thinking about. Now you can divide by 2 because X is on the circle. So we could do 130 divided by 2. And that gets us 65. All right, last one. This pulls in some good old previous knowledge, right? In this case here, I'm going to redraw this figure that we have. It's kind of hard to see up here. So this is C, B, D, and A. We've got this four-sided figure. I know it's kind of hard to see it, but if you look here, you see that B and D are both 90-degree angles. And then we got this line going down the middle here that splits that quadrilateral into two. I want to find the measure of arc BD, that arc right there. Okay, that's not part of my picture, but that's the arc we're trying to find. If I can find this central angle right here, that would be the measure of that arc, because this angle here is at the center of the Earth, okay? The Earth's radius, and I know that it's at the center because it tells us the Earth's radius is 4,000. A to B is 4,000. A to D is 4,000. Those are both your radii, AB and AD. It says that 4,300, and it talks about it in the problem, but 4,300 is this distance here, which is essentially AC. So I'm going to go ahead and label this piece here 4,300. If I were to draw a right triangle, and I'm looking for this angle right here, how can I find the measure of this angle? Okay. It kind of looks like a Pythagorean theorem. If we were looking for this side here, we would use the Pythagorean theorem, but we're not looking for the side. We're looking for the angle. So what have we used fairly recently that we can find the missing angle of a right triangle?
Sine, cosine, and tangent.
Sine, cosine, and tangent. SOHCAHTOA, right? Good. So from this angle here, what side would 4,000 be? Opposite, adjacent, or hypotenuse? Adjacent. Okay, this is adjacent. This is opposite. This is hypotenuse. Okay, we don't really need the opposite side. We just need adjacent and hypotenuse. So this is cosine. So cosine of, I'm going to call this x right here, equals adjacent over hypotenuse. What do we have to do special in our calculator when we find an angle using trig? What do we have to do on our calculator? Okay, and not just cosine, but
Cosine negative 1.
cosine negative 1. Because we're looking for an angle, we're going to do cosine negative 1. We put that in our calculator. Now here's where you got to also be careful. What number do we get there? About 21.5. We know the one here right next to it is also 21.5. So I'm going to double that, and that would be the measure of arc BD. So the measure of arc BD is about 43.1. All right. I know I didn't give you a lot of time here today to work. There's a lot of formulas and a lot of examples today. Tomorrow we're going to do a review of